Okay, so we're just going to wait a little bit for other participant to join us. And so that's why you're not hearing me or Robert, just because we haven't started. So thank you for your patience. Okay, well, thank you so much for coming to today's event. And I'd like to thank Robert, first of all, for agreeing to do this event for the Sustainable Energy Week. Sustainable Energy Week is a series of events that happens in Europe every year, and they're trying to promote renewable energy and clean energy in Europe. And they bring together different stakeholders, NGOs, companies, citizens of Europe that are interested in energy independence, in clean energy, renewable, and everything in between. I thought it was a great idea to invite Robert to talk about nuclear energy in this series of events. My name is Ioana Petrescu. I am the president of Pur și Simplu Verde, and I'm a European Climate Pact ambassador. And today I am here with Robert Zubrin. And we are here today because Robert wrote a very, very interesting book, which is called The Case for Nukes. You see also behind Robert right there. And so Robert has a very, very interesting CV. And I'm going to mention only a few things today before I let him speak a little bit more about his book. I'm going to mention that you probably find his face familiar, and that's because he was in the miniseries Mars that National Geographic did, so you probably recognize him from there. Though today he's not going to talk so much about Mars as much as the book about nuclear energy. And Robert has a PhD in nuclear engineering from University of Washington, and he's the author of 13 books. This is the latest, and he coordinated over 70 technical projects for NASA. He's a president of Pioneer Astronautics right now. And he's very passionate about nuclear energy. The book was very, very well received. Had raving reviews from a number of publications. To be more specific, Forbes called it the most important book you'll ever read. So if that's not an endorsement, I don't know what is, Robert. So I read the book. I absolutely love it, and I'm so glad that we get to talk a little bit with Robert today. So first of all, hi. I not even get you a chance to let you say hi.
Hello, and thanks for inviting me to speak at this seminar.
Thank you so much. We are going to stream live on YouTube, so that's where for all the participants. The participants in the seminar can put questions in the Q&A whenever they please, and we will answer those at the end of the session. So whatever questions you have, they are absolutely welcome. So I'm going to start with, I guess, the elephant in the room in Europe. Most of our audience, I was explaining to you, Robert, they are from Europe. And there are a number of news in Europe that are puzzling us. So on one hand, European Union says that nuclear energy is sustainable, and investment in nuclear energy are considered sustainable and green. Then European Union is putting forth Repower EU, which is a document that says we want to have energy independence. We don't want to depend on Russian gas. And then on top of everything else, you see that some countries are actually giving up on nuclear power. We saw most recently that Germany shut down some of the reactors. We know that Italy did that in the past. We know that there are other European countries that plan a phase out of nuclear energy. So I think I would start with, how is this being seen from the US? So by the way, Robert is streaming from Denver. And how do you see it as a person who knows a lot about nuclear power and has been studying actually the history of this for a while now?
Okay, well, let's start at the beginning. Why do we need nuclear power? Okay, why do we need power? Okay, we need power to sustain the good standard of living, the kind of standard of living people first experienced in the 20th century, actually, after thousands of years of general poverty, and which is still only experienced by a minority of the human race. Okay, in the United States today, the average income is $50,000 a year. And we generally live fairly well here, but there's a certain amount of poverty in the United States. Many European countries, it's similar. But the average income in the world is $10,000 a year. Okay, that is, the average income in the world is well below the US minimum wage. And half the world is below average. If we wanted to raise the entire world up to the average standard of living in, say, the US or Germany, we would have to multiply world energy use 5 times. And that does not even account for population growth. And by the way, I believe that doing that, accomplishing that degree of uplift globally would be really and should be the central goal for humanity for the 21st century. I believe it's achievable, and I believe it's necessary. And the principal problem in the world today is poverty. Poverty kills hundreds of millions of people every year. Okay, some through direct starvation, larger numbers through the secondary effects of poverty, such as malnutrition, leaving people open to death by disease. And those who are not killed live lives that would be considered horrible by anyone who is listening to this lecture right now. Spending lives of backbreaking labor, squeezing sugar cane. I mean, doing things that you would not want to spend your life doing, and their lives are short. Okay, so this is a problem. So 5 times. Okay, and if we actually wanted to eliminate poverty, more like 10 times. Okay, now look, I am not in agreement with people who are shouting from the street corners that the world is burning, because it is not currently burning up. Okay, it isn't. Go outside. It's not burning up. All right, but okay, while the global temperature of the Earth has only increased by 1 degree centigrade since 1970, and maybe it'll go up another degree centigrade in this century, that is not an extinction crisis. That's equivalent to moving, 100 kilometers to the south. People do that. People move a lot further south than that, quite voluntarily. New Yorkers are not moving mostly to central New Jersey. They're moving to Florida. But as a result of our carbon use, the world CO2 levels have increased by 50% since 1870, from 280 parts per million to 420. Now that is material, okay? And also extremely material is not even the CO2 emissions from power plants, but the more familiar conventional pollutants, particulates, carbon monoxide, nitric oxides, etc. Those are actually killing people now. About 4 million people a year by UN estimates are killed by those forms of pollutants. And while the CO2 is not killing people, it's threatening a change in oceanic chemistry. And while we may only be seeing examples of that here and there right now, if we were to increase carbon emissions 5 or 10 times, that would be very drastic. And that would affect oceanic chemistry. It would affect the ability of the phytoplankton and then zooplanktons to make shells, which affects the whole ocean food chain. And that actually is the serious threat, okay, not modest warming. And so this is a problem that needs to be addressed. We have to multiply our energy production without multiplying our carbon emissions. And that can only be done by an energy source which is available at very large scale in very large amounts, with essentially with reserves vastly exceeding those of fossil fuels. Okay, because another problem with fossil fuels is if we increased our energy production 5 times and based them on fossil fuels, we would be starting to get into actual resource limitations. Exactly where those are unclear, because we're always discovering new reserves, but clearly there could become an issue if we were to multiply our energy use and depend largely on fossil fuels. That's a further problem. And another problem with fossil fuels is, to the extent that they are there, and of course, if our use of them were to multiply, while it might not exhaust them, will certainly drive the price up. And this will transfer power to people who happen to have those fossil fuels by right of possession, to economies that depend upon natural resources as a primary thing, and economies that depend on natural resources as their primary product tend to be reactionary, okay, tend to be tyrannies, because it's precisely those economies that do not need to develop and therefore do not need to permit the creative potentials of their populations to play. That's why in the Middle East, for example, the countries with the most oil have the least freedom. Okay, that is why the high price of oil is what sustains Putin's tyranny in Russia. And but if we can transfer the source of resources from those who have it by right of possession to those who make it through the power of creation, we are transferring power in the world from societies based on tyranny to societies based on liberty. Okay, because liberty is what is necessary for creativity.
So let me interject there and go back to our little obsession in Europe, which I think is a good obsession, this one with energy independence from Russia, we mean. So what does nuclear power, what role does it play in it? And how can we do it in a smarter way in Europe than we've been doing it so far? I'm
You can do it in a smarter way very easily.
I need to talk about, by the way, you should definitely read the book, because Robert goes into the details of the history and all that the story that he gave you. But I'm in a European event, so I'm going to bring everything. It's about Europe today.
Okay.
And Robert and I talked before, and so I know how he feels about the war and everything else. But energy independence and nuclear power. How do we accomplish this? I mean, it's mostly energy independence, but how do we get there? And because you mentioned pollution and the negative effects of coal and fossil fuel on health and things like that, I want you to also touch on another issue, which is also in the news in Romania, but everywhere in Europe. You know, you have countries that shut down their nuclear plants and they open up their coal mines. So we don't know anymore what we're doing, to be honest. I don't think I'm the only one who's confused about this. So basically, energy independence. Can we achieve it without nuclear power? Let's make it in a simpler question.
No. Look, there's one country in Europe, one major country, that has decarbonized its power grid. That's France, okay, which produces 75% of its electricity from nuclear power, another 10% from hydroelectric. So it is effectively decarbonized. And France produces 1/5 the carbon emissions per unit electricity as does Germany, even though Germans will talk you blue in the face about their concern for the environment and the trees, especially those trees. They love the trees. And yet they're cutting down millions of them, some in Germany, but more elsewhere, so they don't have to look at the trees that they're destroying and the forests they're destroying, because they think this is natural. Okay, well, the key to preserving the natural is to use the artificial. Okay, nuclear power is far more benign to the environment than coal, and vastly more than burning forests, because it doesn't intersect with resources that are used by the natural biosphere. Okay, I mean, look, oil was great for the wildlife that we stopped hunting whales for oil and started using petroleum. Okay, if we hadn't to switch from whale oil to petroleum, whales would be extinct right now. Rockefeller saved the whales. Okay, but nuclear power has even less of an interaction with the natural biosphere. It comes from rocks. Okay, it comes from ores that are contained in rocks, and they are not used because the very force that is involved in nuclear power, which is the nuclear force, is not used by biology. Biology depends upon chemical forces, chemical interactions. And so when you interact with the chemosphere, as it were, you interact with the biosphere. But when you interact with the lithosphere, you do not. And so you want to be good to nature, leave it alone. Draw your power from something that is not natural, okay, that is artificial, which is to say that comes from the mind. Okay, now, you know, okay, well, nuclear power reactors today, they get their fuel from uranium ore, which are particular locations where you have several percent uranium in the rocks. But practically any rock contains a vast amount of nuclear energy. You take granite, okay, which many buildings are made out of, and I'm not sure if the Alps are granite or not, but many mountain ranges here in the United States are largely granite. The average piece of granite contains 2 parts per million uranium and 8 parts per million thorium, and they have 10 million times the energy per weight as does oil. So when you work out the numbers, what it turns out is that an average rock of granite has 100 times the energy. I said they have 10 million times per unit weight as oil. And so the average rock, a kilogram of granite has the same energy as 100 kilograms of oil. Okay, you're surrounded by mountains of energy. And if we can unleash fusion power, which is the next step here, a gallon of water contains as much energy as 350 gallons of gasoline. So we are not limited in energy. And if you can have energy, you can make any chemical compound. You know, with all the buildings and use of iron that there's been since the beginning of the Iron Age in 1500 BC, we haven't used up a kilogram of iron on the earth. Okay, we've just altered it in forms. We've smelted it out of iron ore, turning it from iron oxide into metallic iron, and then we've let the iron rust and turn it back into iron ore or into iron oxide. So we don't actually use elements, we recycle them. Everything is recycled, okay? But it takes energy to recycle things. And if we can have unlimited energy from nuclear sources, then we can have, yes, we can have the circular economy for real. But it takes energy to make the circle go around. And that's the way to do it. And we have to be rational. The French were rational. And de Gaulle put together a coalition, labor and capital, from the Gaullists through the Communist Party, all favoring nuclear power because they knew that this was necessary for economic growth, and economic growth is good both for labor and capital. Okay, but Germany, because of its addiction to romantic notions about going back to nature, which are unscientific notions, and has you know, I mean, if carbon dioxide is an existential crisis, and it isn't quite yet, it's a problem now, it will become a crisis eventually, then the Germans are climate criminals. And what they did, okay, in shutting down 22 gigawatts of nuclear power, which is, say, about $100 billion worth of power plants were destroyed. This is the largest nuclear disaster in history, okay? It destroyed a vast amount of wealth and committed Germany to vast amounts of carbon emissions, when in fact, what Germany should have been doing is building more and more nuclear power plants, and not only enough nuclear power plants for its own needs, but it's enough nuclear power plants to power industries that could produce products that could lift the whole world out of poverty.
Okay.
Okay.
So, Robert, so I think all of us notice that you are a proponent of nuclear power. So let me be the devil advocate here and say, but why can't we achieve energy independence from Russia in Europe by renewables, by putting solar panels and using wind and other? Is that possible? Because that would be the counter argument to what you're saying. So you're right that one way is certainly nuclear power. And then there are these other sources of energy. And the question is, can we, again, getting back to the original, can we forget about nuclear power and just go, you know, full solar or full wind, and we're not going to need it? Because some people would say that and say, oh, but that's cleaner, and we can go later into like whether that's cleaner or not.
Well, first of all, it's not cleaner, and second of all, it's not possible. They really shouldn't be called renewables. They should be called unreliables. And you know, I mean, first of all, there is no solar energy at night. And furthermore, even in the early hours of the day and the late hours of the day, the sun comes through the atmosphere in an oblique angle, greatly reducing its effectiveness. So really only have about a third of the day on average, and then it can be cloudy. And so forth, and there's this thing called winter, and and basically what you find is that solar power panels typically generate about 1/6 of their rated power on average, and it's even worse than that, because you can't overcome that just by building 6 times as many solar panels because of the intermittent nature of it. And not only intermittent every night, but you can have entire weeks when it's overcast. And so you need to have backup power that is reliable, which is to say either nuclear or fossil, equal to the full capacity of the solar power plant. And the same is true with wind. And I mean, the very idea of relying on climate-dependent power sources when you're faced with the problem of climate change, it boggles the mind that you would switch to reliance on power sources that are climate dependent just when the climate is changing on you. And but furthermore, I mean, look, wind, I'm all for wind power, okay? I am a sailor, and sailing ships revolutionized the world, okay? The wind and solar are off-grid power sources, and they're useful for that purpose. And the power of sail, replacing the power of oars, revolutionized maritime commerce and created the global economy by having ships that could sail from Europe to China and all that. But that civilization has been superseded. Okay, and solar, yes, solar is good for off-grid power, and particularly in outer space. We use solar power for satellites, okay, because satellites are off the grid. But when you're talking about producing power en masse and at scale, these things really became obsolete 150 years ago. And the idea that we can power the civilization of the future, which is going to require vastly more energy than the present, rather than 1/10 as much as what the world civilization did, say, in 1900. You know, in the 20th century, multiplied global energy use 10 times. And we're going to multiply it 10 times again in this century. And the idea, it's ridiculous. And then furthermore, the notion that these are not polluting is simply untrue. The reason why solar panels are produced largely in China is because the chemistry involved in making the photovoltaic quality silicon using fluorine compounds is extremely polluting, and they have caused massive environmental devastation, including gigantic fish kills and damage to public health. And you know, and a lot of the work is done by Uyghur slave laborers. I mean, you know, this is outsourcing your pollution, okay? And then you talk about land use, where the amount of land that is needed to produce a given amount of power from wind or solar is orders of 100 times more than needed to do it on a nuclear power plant. And then, of course, with wind, you do have the problem that they slaughter the birds and so forth. And it's just not a reasonable way to go. And
so let me add something here. I probably mentioned to you, I saw the pre-screening of Nuclear Now, the new documentary that Oliver Stone is doing, and he was there, and he had a panel with a number of MIT professors and Harvard professors. So one thing that they said was, that's not exactly what you're saying, but it doesn't contradict it either. They were basically saying, you know, if we want to get to net zero, we cannot take nuclear out of the question, because if we are taking it out of the equation, we're not going to go there just with this. It is not exactly what you're saying, but they are also claiming that nuclear power is a key ingredient if we want to get to net zero. And I want to follow up on this because you started discussing the negative environmental effects of wind energy, of solar energy. I think it's very hard to find something that has absolutely no environmental impact. So I think the logical next question is, how clean is nuclear energy, and how much should be worried about nuclear waste? I know that you're discussing this in your book. How much should we worry about an accident? I'm asking these questions because we are in Europe. A lot of our audience comes from Romania, from neighboring countries. We're very close to Chernobyl. I remember Chernobyl. I was 6. So I think it's fair to ask how safe it is, and how safe it is for the environment and for people, since you are putting it in balance with the negative environmental effects of other sources of energy.
Okay, sure. Well, first of all, there's been about 1,000 pressurized water reactors on land and sea since 1954, when the first one was built. And not a single person anywhere has ever been harmed by a radiological emission from a pressurized water reactor. Not one. This concern compares with hundreds of thousands of people killed in dam breaks, tens of thousands of people killed by toxic clouds from fossil fuel accidents. And routinely tens of thousands, well, actually about 4 million people a year killed by pollution from fossil fuel plant emissions. 4 million people a year. Now, Chernobyl, okay, first of all, Chernobyl was not a pressurized water reactor. And there's a very important distinction, and it gets a bit technical, but I do work through it in the book so people understand it.
Can you explain why that's relevant? So we're not building those types of reactor anymore? Is that why it's not the concern
Well,
anymore?
the Chernobyl reactor could never have been licensed in any civilized country. Chernobyl reactor didn't even have a containment vessel. But not only that, okay, a little bit of history. Okay, we can digress a bit. Around 1936, Enrico Fermi was doing an experiment in Rome, and which involved using neutrons to interact with uranium. He didn't realize he was actually doing fission, but he didn't know that. But what he did see was that for some reason, the experiment was on a marble table, because this was Rome, and they moved the experiment. They had to move it off the marble table to a wooden table. And guess what? The number of reactions increased as soon as they put it on a wooden table. And then they thought this had to be experimental error. What possible role could having a wooden table do to increase the number of reactions? And then they put it back on the marble table, the number of reactions decreased again. So it was a reproducible effect. And finally, he realized that what was really going on was that the neutrons create more reactions if they're going slower. And since wood has more hydrogens in it than marble, and hydrogen atoms have the same mass as a neutron. So when a neutron hits a hydrogen nuclei, it's hitting something of almost the same mass as itself, and they bounce off and they each split the energy in half. Whereas if it hits a calcium atom in marble, which is much heavier than a neutron, the neutron just bounces like a ball hitting a wall. And so this property known as moderation is necessary to facilitate fission reactions. And if you have uranium, which is only a few percent uranium-235, like it is in a reactor instead of a bomb where it might be 90%, the neutrons need to be moderated. They need to be slowed down in order to allow the fission reaction to occur. And what Admiral Rickover, who created the first nuclear submarine, he said, I'm going to use the same thing for my moderator as I'm using for my coolant, namely water. And see, if the water boils too much, if the reactor gets too hot, now there's holes in my moderator and the reaction will shut down. And there's no operator intervention necessary. And this will occur instantaneously. It's automatic negative feedback, very powerful negative feedback. And it happens within microseconds. And now, of course, when the reaction shuts down, the water cools down and the reaction restarts. And what actually happens is you see the reaction just stays at a level that you set by how much water you pump through the reactor. Okay, you control the pumps, you control the reaction. Chernobyl was moderated not by water, it's moderated by graphite, which does not boil. And then there were other things about their Chernobyl reactor that a little more subtle, but gave it not a negative feedback, but a positive feedback to reactivity. And so when they pulled the rods, the reaction became self-accelerating, and you had a runaway chain reaction. Now, it was not a bomb. A bomb, you have to have a runaway that is so fast that it actually releases the majority of energy in the uranium before the thing has a chance to disassemble. In this case, only a tiny fraction of the net energy was released, but certainly enough to blow the reactor open and blow the building open, which was not a containment building, it was an ordinary building. And now you had hot graphite exposed to the air and it caught fire. So the reactor was not only unstable, it was flammable. It was a ridiculous reactor. Okay, and then the response to it was ridiculous too. The Soviets, actually had civil defense for nuclear war. They had iodine pills stockpiled everywhere to prevent thyroid poisoning from radioiodine. They didn't distribute it. Okay, the one country in the world that was actually prepared for a nuclear accident didn't use what it had. So the people who died at Chernobyl, which was somewhere between 50 and 100 firefighters for the most part, were not victims of the reactor. They were victims of the Soviet Union, which has had a lot more victims. But yeah, but in terms of the West, you take 3 Mile Island, where you had a reactor melt down. The reactor didn't, that supposedly was going to melt all the way to China. It didn't even melt all the way through the steel pressure vessel. Okay, and let alone the containment building, and it would never reach the containment building. And they emitted a little bit of radioiodine, enough to give the people in the area the same dose as if they had spent the weekend in Colorado going skiing, where we have a higher background radiation.
Okay, so basically you are telling, I'm trying to translate for the audience who does not have a PhD in this. So you are saying that the current nuclear plants are much safer than the one in Chernobyl, and they have better safety features than the one in Chernobyl. So then let me again be the devil advocate again. You probably know that a lot of the rhetoric in Europe was revolving around the accident in Fukushima, the effects there, and I think a lot of groups took that to heart, and they started actually advocating the closing down of a lot of nuclear reactors in Europe. We know that happened. So Fukushima is not, it's in Japan, right? It's presumably a very different story than the one in Chernobyl. How do we know that something like Fukushima is not going to happen again, right? So you explain why.
When was the last time that tsunami swept Germany? Okay. I mean, no, really. Okay. I mean, look, that was ridiculous. Okay. There's no expectation that tsunamis are going to sweep Germany. And by the way, Fukushima, okay, 28,000 people died as a result of the earthquake and tsunamis, not one because of radiological releases from the power plant. You had several power plants destroyed by a disaster big enough to destroy the whole city. But the reactors themselves did not contribute any casualties. Okay. Now, but you want to know what has contributed casualties? The decision to shut down the German nuclear power plants, because what they did, okay, was they, instead of producing power, they arranged that Germany's electricity dollars would go to Russia to fund the Russian military budget. I mean, the amount of money that Germany has shipped to Russia down the Molotov-Ribbentrop pipelines, okay, exceeded the entire Russian military budget. And so they not only funded the invasion of Ukraine and the killing of hundreds of thousands of people, they also funded Russia's thermonuclear weapons and hypersonic weapons programs, okay? And, you know, you want to talk about the deaths. These are deaths from lack of nuclear power. These are deaths caused by the decision to abandon nuclear power. And in fact, so many deaths, and they greatly exceed also the deaths caused by all the pollution the Germans have created as a result of switching to biomass and coal replacing its nuclear power.
Yeah, and I want to interject here just a little bit. That we seem to forget, not necessarily you or our audience, I know that it's like very environmentally conscious, but that the coal, especially coal, pollutes a lot, and the effects on health are really, really high. And so if you want to put the effects on health from like maybe potential radiation or accident against the sure effects of coal on people's health all around those plants and in that region, it's basically no contest in terms of the magnitude. So it's always, I mean, I'm an economist, I'm not an engineer and a scientist like you are, but you always in economics have to put, like, you know, it's one alternative versus another. It's not something versus and so here we're talking alternatives. We need energy. Everybody agrees with this. We need energy to grow. And where are you taking it? And are you taking it from coal? Are you taking it from nuclear? Are you taking it from a combination of these sources? So I think this is sort of the discussion. And also I like, and this is my personal opinion, is okay, nothing is perfect. None of these sources of energy is perfect. None. It's zero, absolute zero pollution. I think it's hard to achieve, but I think we need to make some trade-offs in order to have energy and to for the economy, and also to be energy independent. So I like to touch a little bit, because I know you mentioned in your book about nuclear waste. I think people are concerned, and I think the discussions you see is that people are concerned that this might be polluting, that we're never going to get rid of this nuclear waste. And so I'd like you, if you can tell us a little bit about this. I know that lately there is also possibility of recycling these nuclear materials. And so should we worry about nuclear waste is another.
Well, look, the only reason why nuclear waste is even a subject as opposed to coal-fired waste is it's actually possible to deal with nuclear waste. The coal-fired power plants produce literally millions of times the waste of a nuclear plant. And they also produce, and not just toxic chemical waste, but even radioactive waste. There's uranium and thorium in coal, and unlike a nuclear power plant where it stays in the fuel, in the coal-fired plant goes right up the stack. And the radioactive emissions from coal-fired plants are hundreds of times more than any nuclear plant. And they're absolutely uncontrollable, as well as things that do not decay with time, like arsenic and so forth, that are also in coal. But recycling waste, well, okay, the French do recycle their nuclear waste. They reprocess it. In fact, in the Oliver Stone movie, they take you to a place where the French actually reprocess it, and they reduce the quantity of nuclear waste by about 95% by doing that. Now, in the United States, okay, we had plans to reprocess our nuclear waste, but it was aborted by the allegedly environmentalist Carter administration. But let me tell you, I mean, look, the anti-nukes say there's no way to store nuclear waste. Well, guess what? The US Navy stores nuclear waste in a repository in salt caverns in New Mexico. And that is because there's no disputing the fact that a nuclear submarine is vastly superior to a diesel submarine. And so the Navy wants to have them, and they're not about to listen to any nonsense about, we're not going to let you have nuclear submarines. Whereas on land, okay, as far as the consumer is concerned, electricity is electricity. You get it out of your plug, and it all works the same in your house. Okay, so the environmentalists have adopted a tactic of stopping the establishment of nuclear waste repositories in order to create a problem for the nuclear industry, to try to shut it down by increasing its perceived risks and also increasing its costs. But how can one even take these people seriously when they argue that it's in the interest of public safety to store nuclear waste at power plants in the suburbs of major cities instead of putting them in a cavern under a mountain in the desert Nevada? I mean, that's just ridiculous. They are trying to increase the risk to the public in order to make nuclear power unattractive.
Okay, so in conclusion, you are not very worried about nuclear waste, and nor
No.
should we. Okay.
No one has ever been harmed by any nuclear waste.
So let me ask you something else that is of interest, at least in Romania. I know that it's of interest because so there are these small modular reactors, SMRs, that I know that Romania is very interested in it. It signed an agreement with the US. So it's going to get technical assistance and funding to put one of those pretty soon somewhere in Dâmbovița County in Romania. So tell us more about this SMR, and are there the future like, does it help if that they're so small? I mean, do they make a difference? Is it easier to build? Is it we're trying to understand. This is a new topic also in Romania, and we're excited to be part of this project, but we don't know much about it. And I am asking to clarify these things also because I've been in some debates and in some discussions, and people are saying, oh, they're unsafe because they're new and we don't know what is going to happen. And so I'd like the people who are watching us to understand what 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 is all of this fuss about. This
Okay. Well,
yeah,
I do believe that the small modular reactors, SMRs, are part of the future. They have a number of points of merit. First of all, being small, they're suitable for addressing markets that the large reactors can't address. In other words, yes, if you have a 1,000-megawatt reactor, it's a very good power source for a major city, but the city of 1 million people, say, or more. But what if you've got a small city of 100,000 people or a town of 30,000 people? They're much too small to justify a 1,000-megawatt reactor. Well, you know, the kind of nuclear reactors that we have in ships and submarines vary from like 30 megawatts to 100 megawatts. So in fact, small reactors are not new. In fact, the first reactors were in that range. Now, what is being proposed here is to take advantage of another feature of the small reactor, which is that it's small and therefore could be produced in factories instead of constructed on site. And any industrial operation, say welding, that you can do in a factory, you can do it much more efficiently there than you can at a construction site. The conditions are much more controlled, the personnel are stable, all the materials are right there, everything is well organized. So for example, if we take the example of a weld, it takes 8 times as long to do a weld on average at a construction site as it does in a factory, a weld of a given size. So if we can get all the work done in the factories and just go to the site with the few major pieces and hook them together, we can make them much cheaper, even though, of course, you do have working against you economies of scale. The reason why we went to larger reactors was in general, you're going to have economy of scale with a large reactor. But if we can mass produce them, I mean, look, mass produce cars. Imagine if we tried to, in principle, there could be a car built that would seat 1,000 people, and but you'd have to build it at the bus stop, but the whatever. I mean, you get the idea. Is that ideally it would be cheaper per seat than an automobile, but it could actually become much more expensive. And the other idea here is that if we're mass producing things and they're all the same, each one would not present a new problem to regulators. In other words, you would basically, as automobiles, we don't do an environmental study on each car and each driveway. They do environmental impact on the entire design of the automobile, but once then it's a legal design and it can be mass produced. And that's how these people would want to do this. So they're mass producible, they're transportable, they can address the smaller market, small cities, and this might be especially important in the developing world. I think the challenge for the developing world in the 21st century is not to power villages, because people are going to be moving out of the villages. With industrialization, people move out of villages into cities. This is what we've seen in every country that is industrialized. The cities grow at the expense of the villages. And so now the question of powering new cities, okay? And so there's going to be many new cities in Africa and South America and places like this. And the idea of having a good power source for, say, a city of 100,000 people is quite attractive, and one that is standardized and can be just shipped there and set up.
Yeah. So just on the same topic, in the documentary, and I urge also people to go and see it. They introduce this concept that it might be possible to have a very small of this reactor that you can, basically bury in your backyard, and you could power your house for like 20 years. Is that science fiction, or there is like something to that?
Well, there might be something to that, but I, at least, okay, maybe I'm not imaginative enough, but I tend to think of it more appropriate for powering a village of 1,000 people or 10,000 people rather than each house. At certain points, economies of scale do come into play, and there's a reason why most of us don't have a generator in our own house that runs on fossil fuels. But a town even of 10,000 people we could think of having a 1 megawatt, 10 megawatt kind of power supply for such places.
So I'm going to ask you now my last question, and then I see that we have questions from the audience. So my last question is a little bit on how do you see nuclear energy in the future? I mean, we can talk mostly about Europe, but if you want to talk about US, that's fine as well. Because from my perspective, it's very uncertain which way it's going to go. I mean, there are people like you who are talking about the science of nuclear energy and the benefits of nuclear energy. There are, of course, a number of groups, some environmental, some not, that are fighting for closing it down. And we see that, at least in Europe, it's not clear which group is winning and where the future is going to lead us. How do you see this? And also, what do you think the decisive factors are going to be in terms of like which group wins in the next period from your point of view?
Okay, so Winston Churchill once said, Americans will always do the right thing after they have exhausted all the alternatives. And that is true. And I think that's also ultimately true of Europeans as well. Now here's the thing you got to understand, okay? There's two kinds of environmentalism. I discuss this a little bit in the book. There's practical environmentalism, where you have people who are concerned about actual problems like air and water pollution and wish to deal with them in order to make the world a nicer place to live in. And then there's, and I think from that point of view, the very large majority of people, if that is how you define an environmentalist, the very large majority of people, including myself, are environmentalists. Okay, but there's another form of environmentalism, which I call ideological environmentalism, which basically seeks to use incidents of human insult to the environment, whether real or imagined or exaggerated, as evidence in a in a case against human liberty. Okay, the Chinese have a proverb where there's a will to convict, evidence is never lacking, and if you're saying that human liberty is something bad, you muster whatever evidence you can, and this evidence can be that, depending upon who you're talking to, that it leads to multiplication of undesirable types of people, it leads to heresy, it leads to sexual misconduct, or it leads to damage to the sacred natural environment. These are all arguments that have been mustered against human liberty by various factions at various times. But the fundamental thing about a prosecutorial case is not the evidence, but the intent to convict. So the people who have been arguing this case against human liberty came up with, among other things, in addition to the various other arguments that I just alluded to, the environmental damage, the damage to the sacred environment, Oh, what beautiful country this would be if not for all these ugly little shacks. The et cetera, et cetera. Now, historically, that is to say, prior to say the 1970s, this was mostly a right-wing argument. It was an aristocratic argument. The masses are ruining everything, and we don't want them hunting on our sacred forests and so forth, and this and that. Okay, in the late 60s, early 70s, this got reworked as a left-wing argument. It's capitalism is destroying the environment, the evil capitalists, and it can only be stopped by socialism, and so forth. Now, but it's the same argument. Now, when global warming started to emerge, and global warming is a fact, okay, these people who have created professional organizations around this cause gravitated to it. They say, aha, here it is. It's an existential problem for the human race. Now, existential, that's a big one. Existential is a problem that threatens the existence of the human race. And they managed to alarm a great deal of people, including people who were not ideological environmentalists, who were just practical environmentalists, who just wanted to have the world be a good place to live in, and were not particularly interested in using such arguments to stop economic growth or political freedom. And these people have become alarmed about global warming, are looking for practical solutions rather than looking at it as, aha, now we have a reason to end economic growth. And no, that's not where they're coming from. They say, oh, well, there's a problem. So in other words, the Malthusians, the ideological environmentalists, have oversold their case. And now there's an awful lot of people who are concerned about global warming, who are actually concerned about global warming and are not trying to use it as a rationale to accomplish a different agenda. And the answer for those people is nuclear power, and they're going to see it. Okay, they're going to see it. They're not going to be able to hide this. So, Germany, those politicians, they already have egg on their face from funding the Russian military buildup. And they're going to have a lot more when they realize they're going to need to produce more power, and that the only reliable carbon-free way to do it is nuclear power. And they destroyed $100 billion worth, because that's what it would cost to rebuild those plants. Okay, I don't know how much of the plants have been physically destroyed and can be rebuilt, and how much is just shut down. But if they're allowed to be destroyed, and frankly, if you disperse the workforce to the four winds, this total destruction of the nuclear industry doesn't just destroy plant and equipment, it destroys an industry, it destroys organization, trained cadres of people that know how to run a nuclear power plant and so forth. Okay, maybe the Germans will get their nuclear power industry by bringing in French technical advisors, or maybe they'll bring in Chinese technical advisors. Because, by the way, okay, China, okay, there's 450 commercial nuclear power plants in the world. China intends to build 450 more by 2050, and they intend to export them across the world. Now, right now, the Russians actually are leading the export of nuclear power plants across the world. But the Chinese wisely have bought a few of those, and a few American ones, and a few of this and that. And they have now studied them and copied them and produced their own design, which they will export. And I'm willing to bet anybody $1,000 that the Chinese are going to eat the Russians' lunch in terms of competition for exporting nuclear power plants across the world. Now, in Europe, the only serious competitor to China, it would potentially be France. But the French have got, France had a near-death experience because Macron was going with fashionable opinion, oh, we have to shut down nuclear power plants. But then the Russian stuff caused him to do a 180-degree turn, thank God. And France has abandoned that ridiculous decision and stuck with nuclear power. The Germans, must be said, Germans have this incredible ability to stick to a point of view regardless of the evidence, and the great strength of conviction. And so they went through with it in the face of all the evidence. But this too will pass. It's just going to cost them.
I hope so. I think what I'm reading from what you're saying, and that's just because I'm an economist, so my mind always goes in that direction, is, if we can talk more about economic growth and understand and make people understand that does not necessarily mean that we're destroying the planet, and we can have green economic growth, and we can have that in multiple ways, including by using a nuclear power as part of the energy mix. I think that would help us get there, not to see it as sort of a black and white type of thing. You either have growth and capitalism and therefore we kill the planet, or we don't have either, but we're happy and we have nice forest and nice air. So I think we need to find that pragmatical middle ground where we promote this type of sustainable growth. So I'm going to stop there, but I'm going to start taking some of the questions. Okay, so someone is asking, what do you think about German decision to remove all nuclear plants? I think you answered that. Is this decision going to help Europe to achieve zero emissions in the future? I think you answered this, but if you want to add anything about Germany, I think that was probably asked before we got into the whole German.
I could say more, but I think I've said most of what needs to be said in the answer to that. But yeah, no, this is not going to help Europe achieve zero emissions or reduced emissions, or even keep its emissions the same. It's going to increase European emissions.
Okay. Okay, someone is asking how healthy nukes can be politically, financially believed and progress into the energy production mix. I'm not sure how I interpret this question. I'm gonna should I read it one more time, or?
Yeah, please do.
Yeah, how healthy nukes can be politically, financially believed and progress into energy production mix. To some extent, I think you answered the why healthy nukes can be believed, but maybe we didn't touch so much on the political. I mean, maybe the question is to some extent, how can you push them to be politically feasible? Maybe on that one we didn't really touch.
Look, but fundamentally, people have a decision to make. Okay, which is, well, first of all, do they want to deal with this carbon issue or not? Or is this just virtue signaling? Are these just political costumes for the purpose of the festivals and elections? Germany, where they all affect deep reverence for the environment, is the most destructive to the environment, and frankly, it's unforgivable, given that the alternative was available. I mean, there are countries in Africa that have to use coal. They're so poor they can't afford anything else, and here's the coal, let's use it. But Germany had the nuclear power plants. And, the Greens say we shouldn't use nuclear power because it's too expensive. These plants were already built. They didn't have to pay for them. Okay, so the degree of hypocrisy involved in this, and the degree to which, they burn all these trees. Where do you think these trees come from? Okay, some of them come from German forests, but others they're destroying forests elsewhere. And these are the people who will talk endlessly how they love the forests and the this and that, and the one with nature and so forth and so on. And yet there they go. So at a certain point, people really have to decide, do we really want to deal with this issue or don't we? And if we really want to deal with it, then we use the means that are readily available to deal with it.
So he also asked financially. So I am interpreting this, but feel free to ask another question to clarify it if I'm not interpreting your question correctly. But I guess one aspect is that building new nuclear plants is expensive. So I think maybe that's what he refers as financial.
Okay, all right. Now that's a very important question.
It is not.
Now,
Let's talk
okay.
about that. That's important.
All right, expense. Okay, because in the end, money talks, right? Now, I don't know a lot about the regulatory structure in Europe, but I do know a lot about it here in America. And what happened here in the early 70s, we were getting orders for 2 nuclear power plants every month. And actually, if we had continued building nuclear power plants at that rate, we would have completely decarbonized our electric grid by around 1990. And now this was aborted by the Carter administration under pressure from oil and coal interests. The price of oil shot up in 1973-74 due to the Arab OPEC embargo. And so the oil companies became very concerned about losing their position in power generation. They funded environmental groups to go after nuclear power. They did. And also there was an ideological offensive going on. Malthusians had published a manifesto called The Limits to Growth in 1972, saying we're going to run out of everything by the year 2000 unless we stop economic growth. And this was called the Club of Rome. And there were many members of the US Committee for the Club of Rome in the Carter administration. And what they did to abort the nuclear industry was they created a regulatory structure that was absolutely Byzantine. I have a diagram of it in my book, which is actually their diagram. And it looks like the map of the New York subway system in terms of all the different stops you have to go through to get from here to there. And actually it's worse than that because each of those subway stops have an entire subway map inside of them. And so as a result, the time it took to build a nuclear power plant in the US went from 3 years to 16 years. And as I show in the book, the data is there showing the cost of a nuclear power plant goes as its construction time squared. And there's a number of reasons.
Are you suggesting that by regulating smartly, you can cut the cost of building? Is that where you're going?
Vastly. No, look, if the aviation authorities operated the way the nuclear authorities do, we'd have no airplanes. Absolutely, commercial air travel would be absolutely impossible. And where, I mean, I go through it in the book, it's absolutely ridiculous. And not only do the utilities have to satisfy very time-consuming steps with the authorities themselves, the process, if the authorities give a favorable decision, it's then open to be contested by interveners who can then take it into the courts and then take those decisions to higher courts and so forth. And it can take years and years to resolve these things. And it is designed by intent to strangle them. Building nuclear power plants, the first commercial nuclear power plant we built in the United States took 3 years. It should be quicker now, not longer. And instead it's more than 5 times as long. And I believe, though I don't have the data readily at hand, that we probably would see similar trends in Europe, though perhaps not as marked. Certainly not as marked in France, where basically de Gaulle created a societal decision that spanned the political spectrum saying, we are going to do this. Okay, and so made it happen.
So okay, so let me catch on that point, because that's an important one. So do we need actually some political leaders to actually embrace this and sort of push it and explain to the public, create an audience for these type of policies, right? Because regulation, and now I'm putting my policymaker hat, right? You can regulate anything, but you have to have an audience for that. You have to have voters supporting you for that, but you can build that audience, right? For any type of regulation or public policy. So are you saying we are lacking these sort of forward-looking leaders to push?
Well, certainly. Now, in some cases, it's a lack of leaders. And in some cases, it's the presence of leaders who are absolutely pernicious. Because my understanding is that 70% of the German public opposes the shutting down of their nuclear power plants. And it's just the political leaders many of whom have links to the Kremlin, who supported the murder of the German nuclear industry, which clearly there's only one country that benefits, and that's Russia.
So glad we're not on TV, because I would need to ask you for evidence and stuff. We were on TV. We're not. We're on YouTube.
Okay.
So another question is.
Well, Schroeder is a member of the board of Gazprom.
Yeah, that is actually a fact. Okay. So Dan, I know Dan because he's a faculty in Romania. He's teaching communication and misinformation. Do you think this topic is going to influence the discussion about energy in the next year election in the US? If so, what are the differences between Republicans and Democrats in dealing with these issues? Of course, Dan would ask that. Okay.
All
so.
right. Well, no. Well, now this is an interesting thing. Okay. Okay, the Republicans in general are supportive of nuclear power, although not with the vigor required. That is, for example, Trump, while saying he wanted to get the nuclear waste repository in Nevada built, didn't do so. They did not simplify the regulatory system. In other words, they made some noises, but they didn't do the work. Now, the Democrats, okay, are interesting. Okay, first of all, nuclear power in the United States is created by the Democratic Party. And the nuclear Democrat administrations from FDR through LBJ were responsible for the creation and the growth of the nuclear industry. And Republicans at that time, not exactly opponents, were not really fans because they thought this was like big government and so forth. Then what happened was in the early 70s, the Democrats did a 180 and turned against nuclear power. And this was very bad, and it was extremely harmful to the nuclear industry. Now, as a result of the increased concern over global warming, a faction has emerged within the Democratic Party that is moderately pro-nuclear. And this includes center Democrats like Cory Booker, who's a leader of this organization called the Third Way, centrist Democrats who say, look, it's global warming, got to have nuclear power. And even some radical Democrats like AOC, Alexandria Cortez, because you see, the proposal being offered by the primary camp of climate activists of we're going to combat warming by increasing the cost of fossil fuels is a reactionary program. It is a regressive program. It represents an extremely regressive tax impacting the poor the worst. Sales taxes in general are regressive, and carbon taxes are the most regressive of sales taxes because they tax basic goods, first of all, and second of all, they tax on the basis of mass rather than price. That is, for example, a cheap dress sold at the Gap for $50 contains no more carbon than a high fashion dress selling for $500 or $5,000. And if you tax them based on their carbon compound, they're taxed the same in dollar amounts. Whereas if you tax them on the basis of price, at least they would be taxed in proportion to the price. And so carbon taxes are a totally reactionary policy. And for some of those on the left who still conceive of the left as being the defenders of the poor rather than the defenders of novel cultural ideas,
to them, the very annoying economist in the room, I think a counter argument for the carbon tax regressivity. You're right, absolutely, by themselves, they would be regressive. However, if you are using the revenue in a redistributive manner, then you can make it more progressive, and that would be sort of an argument to build a more complicated policy. I had to say that because I'm an economist, and you were talking about taxes, so I can't really let you off the hook on that one. But
it's an iron law of economics.
Not.
Okay, it's an iron law of economics that government money goes to those who control the government.
I had to say it, and it's it's carbon tax, and I talked about this multiple times, and it's fair to put both sides of the argument.
Oh well, wait a second. Number one, okay, you want to increase government revenue. There's different kind of taxes to do it. And you could do it with progressive income tax, or you could do it with a carbon tax. And a progressive income tax is progressive and a carbon tax is regressive. And that's all there is to it. And then how you spend the money, that's another issue, okay, in terms of who gets the money, but who the money is taken from, it's very clear that carbon tax money is taken from the poor. It's looting the poor to enrich, take the tax burden off the rich. That's what it is. Taxes are not about weather. Taxes are about money.
Taxes are definitely about money, but you know, it's just for the audience. I know you know that, but it's a good economic tool to actually deal with carbon, because it actually put a carbon price on it. But we're further away from our subject of discussion, and I think we should probably go back to it. Okay, Alexandra is asking, if nuclear energy becomes our main source of power, how do we provide the proper education, training, and skills for workers to maintain nuclear reactors for such a mass use? And what about countries where nuclear knowledge is underdeveloped? So how do we do that if we want to do it, you know?
Well, okay.
Everyone in the
This
world.
is done at multiple levels. I mean, look, there's nuclear industries in many countries. I mean, very large ones in the US and France, and Sweden has substantial nuclear power. You can create the required knowledge levels at various levels, a high school, college, PhD. You can create academies or nuclear engineering classes in universities. There's all sorts of ways to do it. It's been done. Certainly, if we're going to establish nuclear power plants in underdeveloped countries, we need to have training courses for the people that are going to operate them.
And Claudia, and Claudia, for full disclosure, ran the Association in Romania for wind energy, I think. Which is, according to you, a reasonable time length and cost to build large nuclear power now, and how this could be financed? So you mentioned that in US it takes too long, right? And it is expensive because the regulations are not set up properly, or maybe they set up in a wrong way to begin with. What would be reasonable in your opinion in terms of length of time?
I see there's no reason why building a nuclear power plant should take more than 4 years. That's what it takes right now in South Korea. That's somewhat longer than it took to build the first nuclear power plants. And I think our goal should be to build nuclear power plants in 1 year. The Empire State Building took 2 years to build. Now, it is interesting that the rebuilt World Trade Center took much longer to build than the Empire State Building. And that has to do with the regulatory structures in general that have become increasingly sclerotic. But in particular, with the case of nuclear power plants, we need a regulatory system that is like the one for aviation, which understands that its mission is not to prevent aviation, but to make sure that we have an airline industry that runs well and is safe. And it is not there on a crusade to destroy the aviation industry. I think building nuclear power plants, building a small modular nuclear power plant is comparable to building an airliner, and could be done with its similar facilities and operated. I mean, operating an airline is comparable to operating a utility system based on nuclear power. And there are many developing sector countries that have their own airlines. So this is something that could be done. And by the way, I think that having such things, airlines and nuclear industries, is very good for a developing sector country in terms of creating a technical cadre that can undertake all sorts of projects necessary for development.
Raud was asking you, what are, in your opinion, your top 3 most reliable sources of energy for the next 20-30 years? Follow up, how soon could nuclear fission become a viable solution? And second follow up, are there any experimental sources that are being developed, even theoretical, more attractive than nuclear fission? So let's start with the 3 most reliable sources of energy for the next 20 to 30 years. That's his first question.
Well, the most reliable source of energy for next year is fossil fuels. We got this whole gigantic industry set up, and it's producing lots of fossil fuels all over the world, and it's doing this and that. But if we want to talk about replacing fossil fuels, it's certainly nuclear power. And there are some people that object to the pressurized water reactor and that it's a 1950s design. I am not in that camp. I think the pressurized water reactor is still prevalent, despite the fact that it is 70 years old as a design, is because it was a very good design. Rickover got it right from the start. Now, that's not to say that it is the ultimate nuclear design. I think there are many potential improved designs over the pressurized water reactor. These include breeder reactors, includes thorium reactors, homogeneous reactors, and even perhaps high temperature gas cooled reactors. These all should be explored. However, the regulatory structure inhibits this, and I'll tell you why. Okay, why don't we have breeder reactors? Okay, which can get literally 90 times as much energy out of a piece of uranium as a pressurized water reactor can, because a pressurized water reactor only uses about 1% of the energy that's in the uranium. A breeder could use 90%. Okay, well, why not? Okay, well, I'll tell you why not. Because as a result of regulatory overkill, the cost of construction of a nuclear power plant is 95% the cost of the electricity. The fuel cost is 5%. Okay, so if you introduce a new type of reactor, you're going to increase the regulatory burden of getting it approved, even though you might decrease the cost of the fuel by a factor of 5. So what if we cut the 5 down to 1, but we turn the 90 up to 270? That's a loss. So given that the main burden of the main cost of nuclear power is getting the damn thing built, nobody wants to try to get a new type of plant licensed if all it's going to do is cut down on the 5% of their cost that's involved with fuel. But if we could rationalize the construction costs so that that 90 goes to 5, and now the 5 that is from fuel is now 50% of the cost of the system, then you might say, okay, now let's address that. Now let's see if we can cut that 5 down to 2, and then the cost goes from 10 to 7, and that's material. There really is no reason why nuclear power shouldn't be too cheap to meter, because the primary energy source involved is so vastly cheaper than fossil fuels are. And it's just the enormous inflation of the cost of building the machine that has elevated its cost to where it's comparable to fossil fuel costs.
But to push you a little bit on Radu's question, which was the 3 most reliable sources. So you did mention coal, but we're trying to phase out of that because that's just not good.
Well, coal is certainly the worst of the fossil fuels.
Okay. So you said nuclear, that it's reliable. So give us some other examples of sources of energy that will be reliable. And the question was 20 to 30 years, so we can look into the future.
Okay, if we're talking the 20 to 30 year period, we could basically replace the fossil fuels in electric grids of all advanced countries with nuclear, with maybe some amount of hydroelectric, because if you've got it, use it. But that's not scalable because most of the good hydroelectric sites are already tapped. That's the thing to do. Now, beyond that, there's fusion. Thermonuclear fusion, as I mentioned, a gallon of water, 350 gallons of gasoline energy equivalent. And there's absolutely no shortage of it. And by the way, that's just water on Earth. On Mars, deuterium is 5 times as common as it is on Earth. And so a gallon of water on Mars is about 1,600 gallons of oil equivalent. And there's water everywhere in the universe, so sure. Now, the fusion program has been moving very slowly. It moved at a fair pace until the 1980s, due to international competition between the Americans, the Europeans, the Japanese, and the Soviets. But in the 1980s, it was decided to consolidate these competing programs into a single program known as ITER, which is now moving at a snail's pace because there's no competitive pressure on it. And it took them 30 years just to decide where to put it. However, what's happening now in fusion is there's, as a result of the example set by SpaceX of the power of entrepreneurial activity, they're private investors, not Musk, he's not interested in fusion, but other private investors have started entrepreneurial fusion companies or have funded entrepreneurial fusion companies, including there's one noteworthy one in the UK, Tokamak Energy. And I discuss a number of them, including that one in my book, that are not moving forward on 50-year timelines, but on 5-year timelines. And I think they'll probably get to demonstrated fusion ignition by the end of this decade, and first practical nuclear power plant, fusion power plants by perhaps 2040.
Wow. Okay. So I think these are going to be all the questions I'm going to take. We have far more, but we promised people just a 90-minute webinar. And I want to say, yes.
Here's the book. Okay, now this may be difficult to get in paper in Europe, but I believe the Kindle versions are readily available in Europe.
Oh, good. So this is the book that we were mentioning. It's called The Case for Nukes, Robert Zubrin. And it's definitely worth reading. It is, I read it. It's not only that it has a technical part, but what Robert is managing to do is to put some history in there, to give you some stories, to tell you about policy, to tell you about the science, and bonus, because Robert is also interested in space. He's mentioning how you can use nuclear power for space transportation, for colonizing Mars, things that we didn't get a chance to get into today, but there are things that are very close to Robert's heart. So Robert, one more time, thank you so much for coming to this Sustainable Energy Week event. I hope that's going to be even more interest in nuclear power in the next period, and we're going to have more and more discussions like this, because I think it's important to educate the public on different views on nuclear power, on what scientists are saying, what other stakeholders are saying, and sort of when we're making these important political decisions, actually to make them in a very, very smart and informed way. Because I think that a lot of time when we are acting in this type of policy that are led to either environmental or energy, they're fear-based. And sometimes there is good reason to have fear for some things, and sometimes it's not. Sometimes some actors are pushing fear in order to push certain policies and push voters in a certain direction. So I think the more discussions that we have with people that have different perspectives and have different backgrounds, they're very, very helpful. So that's why I want to thank you very much for discussing nuclear power with us. And you are welcome to come and visit us in Romania whenever you want to give a physical talk. It's an invitation I'm extending. We're looking forward to hear.
Okay, well, I hope I'll be able to take that invitation someday.
I hope so.
But once again, thanks for inviting me to do this seminar, and I hope I've expanded people's knowledge of this point of view of this subject. Okay.